Before I get moving here, I just want to acknowledge all my co-authors on the work here. It's a great group of collaborators I've had the pleasure of working with for the past 7 years. Now, this is not an exhaustive list, but it's something that I put together after watching the talks yesterday. And one thing that became apparent to me was that there was a whole number of factors that were put out there that might potentially be impacting caribou populations. And, you know, there's not an exhaustive list, but there's a lot. I think it's safe to say that things that we don't know is how these different factors influence one another or interact with each other to affect caribou populations, or the magnitude of them, especially when we get down to the herd level size of things like we've seen from John Cook's presentation earlier. I think this is a nugget for us as we delve deeper into caribou, looking at herd level effects, which might, getting at these mechanisms and how they're impacting the populations might help us to come up with solutions to conserve caribou. Our study was initiated in 2006 by Sam Wasser and North American Oil Sands in the SAG-D development area south of Fort McMurray. The intent of that study was to monitor the impacts of industrial development on caribou, moose, and wolves with a proactive thought that North American Oil Sands, which is now Stat Oil, could come up with innovative solutions to help them reduce their impacts on these species. Sam's an innovator. He's been using trained detection dogs to sample for feces of different species across the world now for several decades. So we conducted sampling using detection dogs, trained dogs to detect feces of wildlife across the landscape, across the winters from January to March in 2006, 2007, and 2009 in our study area. And we're now just planning another sampling year this coming winter. The approach to the study is very simple. We searched the environment and collected scat samples from caribou, moose, and wolves using the dogs. Once they were collected, samples were sent to the lab, and then we used detailed lab analysis, genetic analyses, etc., to get useful information from the samples. So why dogs? Well, plain and simple, they're very efficient. These dogs, you don't have to go very far away to see them. We see them at airports. They're used for getting narcotics. The RCMP use them. I think Sam explains it best when he says, our dogs are trained in depth when we get going. They train with the narcotics dogs. Narcotics dogs start on marijuana, our dogs start on marijuana. Narcotics dogs move to heroin, our dogs move to feces. Why scat? Well, as it says here, everyone poops, and it's the truth. In fact, it's the most abundant sign left behind on the landscape by these critters. And we can collect it without ever having to capture them, without ever having to put a collar on them, without ever having to see them. We just have to walk around and collect what they left behind. More importantly, there's a lot you can do with poo. So in our study that we've been doing here in the oil sands, we're using genetic information. We get DNA from the samples, which allows us to get species confirmations, sex of the individual identities, which allows us to get market capture population estimates for woodland caribou. We get endocrine measures. We get hormones that tell us about stress, reproduction, and nutritional condition of caribou, moose, and wolves. We had diet information. We used diet information to look at the prey composition in wolf scats across our study area. And we had scat locations and transect information from where the dogs searched, which allowed us to get resource selection models and determine habitat suitability and other spatial influences. Now, in the sake of your time, I'm not going to go over a lot of the details of the study. You can find those in our publication last December in Frontiers in Ecology and Environment, where we went over the genetic market capture work and the influences of oil development and human activity on caribou, moose, and wolves, and some of our endocrine work. But what I am going to do is I'm going to focus the study on one particular inference, and that was the nutrition in caribou was lower near industrial activity and according to habitat types that the animals were in. So what we thought is, can we retrospectively go back, take a look at our data, augment our data set to get a little bit more detail. So these are the new results from our work. So over the last 2 years, I guess, we've augmented our data set. And we've done it a couple of ways. We've done additional pellet analysis on 500 samples that we collected in 2009. So we sent samples to Bruce David's lab at Washington State University in Pullman, and he looked at diet composition using microsites or slides of the samples. We also did some additional genetic analysis to get the detailed gender work for each sample. And And we did some work to survey the lichen distribution across our sampling area to get a better idea of forage availability. So in a nutshell, we've got multiple metrics that we're getting from one sampling design. We've got location data, we've got endocrine data, genetic data, and diet data for each sample. So in terms of location, we know where they were relative to lichen availability. Genetic, we're able to disperse what was male and female. And we've got the diet. In terms of the endocrines, we were focusing in on glucocorticoids. Glucocorticoids are a hormone that animals secrete in response to a stress. So as I'm talking up here, heart rate goes up, elevated stress level. The other thing that glucocorticoids are secreted in response to is a nutritional deficit, and in particular glucose deficits. So jumping right to the chase here, one of the first fascinating things that we really keyed into in looking at this was that lichen, the percent lichens in the diet, and we're talking terrestrial and arboreal lichens, we pooled those together. Terrestrial were higher than arboreal, similar to what was just presented from Ontario for was on caribou. A higher glucocorticoid level equals more stress. So in this case, we're seeing a nutritional deficit when there's less lichens. And this makes a lot of sense because we start looking into lichens. Lichens are rich in polysaccharides. Polysaccharides are a carbohydrate equals glucose. As you can see in this data, it's very, very strong. In terms of the physiologists that we've talked to and the endocrinologists, they're super impressed with this. The interesting thing is as lichens go up, GCs go down, which is a great thing. As we started talking and looking more into this data, it started getting interesting to us because we were sampling in the winter, which overlaps the gestation period of caribou. We looked at some studies, talked to an obstetrician in humans, did some work done in kangaroos in Australia, as we started learning is that the primary nutrient absorbed by the developing fetus in the womb is glucose. So this led us to another portion of our study where we said, hey, we've got a really strong relationship here with lichens, maybe we need to add in progesterone. Of course, progesterone being an indicator of pregnancy health. We know that increased progesterone equals less contractions. That with lower progesterone levels, we can have earlier births, we can have abortions, and we can have less development of the fetus. So I'll run you through this here. So we took our lichen availability index, so we're looking spatially across our study area. We say areas with high availability of lichens. Well, the lichens in the diet go way up. Where lichens were not available, less lichens in the diet. Makes sense, right? Nice, easy trend. Then I just showed you the response with GCs. Elevated GCs equals nutritional deficit. We see that over here, which is low spatially across our studies, areas where lichen is less available, and they're eating less lichen. All right, now what happens when we bring in pregnancy? So we bring in progesterone levels. Increased progesterone, good thing. Healthier pregnancies in the population. What do we start seeing here? A real positive trend. Areas with more lichen availability during the gestational period, pregnancies go, progesterone levels go way up. I will also say that we also accounted for time because we know that progesterone increases across just as you get later into gestation. So we had accounted for time based on when we collected the samples. We sampled from January through early March. Now, some of you might be thinking, okay, that's great, but caribou move. So just because a caribou was in a lichen poor area at time A, maybe last week it was in a lichen rich area. So we knew that we had sampled in 3 different ranges. These are the ranges on the east side of the Athabasca River, for those of you familiar with the oil sands south of Fort McMurray. Based on telemetry data in that area, we know that caribou have high fidelity in winter to their ranges. So caribou in the Algar range, caribou in the Algar range stay in the Algar range in winter. In the Pony range, they stay there, and the Waiu range, they stay there. Interestingly, we had different lichen availabilities in all 3 ranges, dramatically different. Lichen clusters on the landscape, it's not equally distributed. In the Waiu range, we had a large fire come through in 2003 and wiped out most of the lichens in that area. In the Algar range, we have some older forests, some older stands, a little bit wetter, less sort of moderate level of lichens. In the same Pony range, we had higher abundance of lichens. And here you see the same patterns that I just showed you by range: higher lichen availability, moderate lichen availability, low lichen availability. In the diet goes way up in total lichens, Moderate, here's the fire. Low, glucocorticoids, there it is. You see your deficit happening when lichens are low. Availability is low, forage is low in these range effects, so we're talking like 3 herds within a given range. And then progesterone levels way down. And somewhere down here is what we got for male levels of progesterone. So these guys down here are really low in this YU range. So we're starting to see this demographic response. We know that lower levels of progesterone from other studies relate to lower calf recruitment the following year. So what? Well, first, diet can have a larger effect on GCs than previously thought. GCs are often used for stress. We look at them, we say, okay, how do animals' GCs go up in terms of traffic volume or other types of activities? Important thing here is not that GCs don't account for stress, but that we make sure that we account for the variability due to diet when we're working with GCs. Now this is similar to what John said earlier. I think that health and nutritional mechanisms have maybe been underappreciated in some of the literature that we look at, and I think it's an area that we need to pay attention to. We're not saying that it's a silver bullet or anything else, but it's an important thing. We know that they consume a lot of lichens. We know that caribou are species specific in terms of their diet, especially in winter, and I think it can maybe deserve some additional attention. And these types of mechanisms may interact with other mechanisms, for example, predation. We know that we've got calves being born in maybe compromised conditions. They could be more vulnerable to predation. There's been some papers on Yellowstone suggesting similar types of things. Third, again, John stole my thunder on this, but range level variability on nutritional effect. We see within a population in the ESAR, we have different ranges with different effects in terms of nutrition and pregnancy. Plain and simple here is theoretically we need to get down to that level of detail inside those ranges. There may be different magnitudes of these different effects that are interacting to affect a species in a range. And by understanding those, we might learn that we need to do different things to manage and conserve caribou. There's different solutions possibly, or different priorities in terms of solutions that might need to be set. And lastly, the big lesson here is that we need to be considering multiple interacting mechanisms when we're looking at these critters. I think somebody that I was speaking to yesterday said, if we don't look, we won't know. And that's all I've got. I'd like to acknowledge my collaborators, the people that funded our study, in particular Stat Oil. I'd like to also say that this is just a very focused tidbit of the work that we've been doing in this area. I think there was a handout that came out from Stat Oil that summarizes a bunch of the other work that we've done. You might want to take a look, or else talk to me later on.